Okay, welcome to my channel. We will be solving this previous exam. It is from May, June 2025. Okay, and it is mathematics, paper 4, mechanics. Okay, so this is what we are going to solve right now. Okay, so let's jump into it. The question number one, yes, it talks about a plate being pushed in a horizontal straight line along the horizontal surface. Okay, so the scenario is the following. We have a, let me do it here so that we can see for the next question as well. On a plane horizontal surface, there is a crate and we are being applied a force of 25 Newton at an angle of 20 degree. Okay, so that crate moves at distance of 12 meter in 8 seconds with constant speed. Okay, very easy, no acceleration, so life is very easy. So the speed is distance over time, and it was 12 meter over 8 seconds, so it is 1.5 meter per second. Very, very easy. Okay, find the work done by the 25 Newton force. Okay, you see, work is done by the horizontal component of this force. Okay, so this force is 25 Newton and it has an angle of 20 degree with the horizontal, right? So I need to find the horizontal component of this force. Why? Because the displacement is in the horizontal direction. So the work is being done by the horizontal component of this force. Okay, so let me call this fx. So you can see that this fx would be equal to f into cosine of theta. F is 25 meter and cosine of theta is 20 degree. Okay, so this will give us the so many newtons will give us the amount of force which is actually doing the work. Okay, so how much work is being done? Nautical, the work is done by force into displacement, right? Okay. Now the force is 25 cos of 20 degree, and you have to multiply with displacement. You see, this is moved by 12 meters, so we have to multiply it with 12. Okay. And when we did all this calculation, it came out to be 282. Let me confirm. It was 281.9 basically. 21.9, which we can reasonably approximate as 282 joules. Okay, easy. Now the third part is to find the power at which the 25 Newton force is working. Remember, work is force into distance. If I divide everything by t, so work done per unit second, and this will be force into d by t. So work done per second is power in watts. So this is F, and distance divided by time is the velocity, right? So we have to do this thing. Okay. Now, when you want to calculate the power, which force we will be using? The Fx, okay, which was 25 times cosine of 20 degree. And you have to multiply this thing with the speed. Speed we just found out it was 1.5 meter per second. Okay, so this all will give me 1.5, 25. Yes, it will give me 35.2 watts. Okay, so this was pretty easy question. Let's go to the question number two. Okay, there are two particles on a horizontal surface. So we have a horizontal surface. There were two particles or two objects. One is P and the other one is Q. Okay, the mass of this object is 0.2 kilogram, 0.2 kilogram, and this one is 0.1 kilogram. This is moving with a speed of 5 meter per second, and this is moving with a speed of 2 meter per second. Okay, so this is fast, so it gets up with this one. So when it hits it, it combine with it. Okay, and I don't know this word. It is pretty new for me. I don't know how to pronounce it. Anyway, so when they so after the collision, what happens? Uh, they become one object, which is P and Q. You can say, and the total mass is zero point 0.2 plus zero point 0.1, 0.3 kilogram, and it is moving with some speed v, which we do not know right now. Okay, so if I assume that if I use the law of conservation of momentum, so the initial momentum before the impact, the initial momentum is mass is 0.2 times speed is 5 plus for this object mass is 0.1 and speed is 2, right? So this is the total momentum before the collision. After the collision, total momentum is the mass is 0.3 times whatever the speed is. Okay. So using the law of conservation of momentum, I came up with this equation. So from here I can find the speed. It is zero point 0.2 times 5 is 1 plus 2 times 0.1 is 0.2 divided by 0.3. So it gives us, I believe, 4. Uh, yes, it gives me 4 meter per second. This is the speed of this new block. Okay. Now, question is find the kinetic energy lost during the collision. Okay, this is interesting. Uh, so we need to calculate the change in the kinetic energy or the kinetic energy final minus kinetic energy initial. So initially I'm assuming I'll get the form. Initially it was larger, right? Yes, I should write the initial first. My mistake. Give me a sec. Yes. Okay. So kinetic energy initial minus kinetic energy final. Okay. So how much was the kinetic energy initial? The kinetic energy, remember, it is given by half mv square. So for this object P, it is going to be 1/2. Its mass is 0.2 and its speed was 5. So I will put 5 square. Okay. So this is the kinetic energy of object P plus the kinetic energy of Q. Again, it's going to be half. Its mass is 0.1 and speed is 2. So 2 squared is 2 squared. Okay, so this is the initial kinetic energy minus the final kinetic energy is the kinetic energy of this guy. So this is half and its mass is 0.3 and its speed is v, which we already calculated as 4 meter per second. So it is 4 squared. Okay. And when we did all this calculation, it comes out to be 0.3 joules. Okay. So this much was the energy lost during the collision. Okay. I hope this is it all makes sense to you guys. Uh, if you ever have any question, you can always ask me in the comment section. Thank you very much for watching. See you in the next video.